Okay, let's go over the notes over topic 1.2, our random samples. We're going to learn about sampling techniques today. So there is something that's called convenient sampling. This is when we might use the population members that are readily available, basically the easiest. Use whatever's handy. And it probably is the worst way to sample a population. So for instance, if I were going to create a sample or a survey of students at NSC that commute, and I only ask my one elementary statistics class that I have online, probably those students may not even commute. They may just stay away and never even set foot on campus unless they come to take their proctored exam. Or if I were sampling my one in-person elementary statistics class, a lot of them might commute, some of them might not commute because they live on campus. So that might be a little better sample, but it's still not going to represent a good variety of Northern Oklahoma College students because we have a lot of nighttime classes, we have a lot of other classes that happen at different times. So anyways, it's just not the best way to get an actual overall good representation of how many people really commute to Northern over all the other students that aren't being sampled. Systematic sampling. This would be members of the population. They're sequentially numbered. So basically you're numbering 1, 2, 3, 4, 5, and everybody gets a number. So we start from a starting point, and maybe we pick every 5th member to be included in the sample. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. That would be considered systematic sampling. Stratified sampling, the entire population is divided into groups. Then samples are drawn from every group. So let's go on the idea of being a student. When you're a freshman, that's a group of people. Sophomores is a group of people. Juniors and seniors. So you sample from each group. So maybe I'm going to take, let's say there's this whole class consists of 100 students. And maybe I decide to sample 10 from each group or something like that. That's what that means, that you're sampling students from each group. But cluster sampling is saying maybe you have all these districts, for instance, and you only sample district A, so everyone in that sample in district F. So maybe you only do 2 of the 6, but it's every person in each of those groups. So cluster sampling would be the entire population being divided into, it says geographic regions, but it could be still like this, maybe freshmen, sophomore, junior, seniors. And then maybe a few clusters are selected and every member of each cluster is included in the sample. Simple random sample, every individual in the population has an equal chance of being selected. So this would be the best method. Say we were able to send out an email to all NSCO students and everybody had the choice to participate or not. That would be, in some cases, the best because it's random. All of the people were given the survey and able to reply. Nobody was targeted for that study. So let's turn the page. You need to have your random number table to be able to answer this, which I need to get mine off the back of my paper. And it looks like this. It's your random numbers table. We're going to be using it with these next problems. So we're going to be asked to get a simple random sample of 10 students from the class. And it would tell you out of how many. So let's say out of 50 students. So let's add that to our notes. And so the way that you're going to do this, we're going to just jump right into how a random number table can be used. You're going to choose in here, these are all different rows and blocks. So like this would be a block and this is a block that's in gray. So I would call this like block 1, block 2, block 3, block 4, 5, 6. It's like we have 7 blocks on this sheet. And then in each of those blocks, we have a row. So like this could be row 1, row 2, row 3, row 4, row 5. And for this example, I'm just going to stick with block 1. I think it's at the top, it's easier to see. And I want you to always identify what block you're looking at, because all of these things can be different, but I'll show you how we're going to use this table. So we're going to choose block 1, maybe row 3. You can choose any row you want. That's why it's called a random numbers table. You just choose. And so what we're going to do is write down, you could write down every single digit here, but you really don't have to go that deep in it. I'm going to probably write like 3 or 4 sets of these numbers together. And it's just to have random numbers side by side. 654, that's from this table. 71966 27386 and maybe 50004. I'll do one more and then 05358. Okay, so what you're going to do is, if you were having to do this manually, there's actually apps and things that do this for you now, but to get a random sample of 10 students from the class out of 50 students, what you want to do is, because this is a 2-digit number, we're going to separate these numbers here by 2s. Like that. And you may sometimes need to go further with your rows. We'll just see if it works for us, but we're going to sample 10 students from the class out of 50. So this is basically going to be like, since 59 is bigger than 50, there wouldn't be a 59th student. We wouldn't sample that person. 65 is bigger. So we could sample number 47. We could sample number 19. Number 66 is bigger than the 50 students. 27, and we have to do 10 of these. So we're getting a simple random sample of 10 students. So this would basically be like, if we were to go number them, maybe that would be a way to describe this. 1, 2, 3, 4, 5. Which students would get picked by their numbers. And this would be how you could find or get a sample, or the number of who will be sampled. So 47, 19, 27, we have 38. 65 is bigger than 50. We couldn't sample a 0 student, right? We're not going to say you're number 0. You always start with number 1. We could do the 4th student. Looks like I'm going to have to extend my list. The 5th student, really didn't have to put the zeros in front of there. I just did. I think I have it. The 35th student. And so I still need 3 more. So I'd have to go back to my table and see where I left off, which was after this one right here. And I could continue my list. And I'm going to do it right here. 9, 4, 0, 3, 1. And I'll probably have to come. We need to be able to separate them in 2s. I'll probably put this row under here. 29, 2, 8, 1, 1, 8, 5, 4, 4. So I've already kind of separated them as I wrote them down. So we got 4, 5, 35, 89 is too big, 40, 31, and then 29. And then we'd stop because we only need 10 people to sample. So that's how you would maybe use like a random number table to decide who to sample. Say you have 50 students, you're gonna number them 1 through 50 and that's their number. The reason we wouldn't pick anything over 50 is because nobody's gonna be the 51st student if there's only 50 students. And so the person that was given the number 47, when we went through and counted them out, labeled them 1, 2, 3, 4, 5, 6, 7, 8, would be picked, 19, all of those things, and that would just kind of be in the order that they would be sampled, surveyed. So it says simulate the outcomes of flipping a quarter 6 times. And so we can still do this with a random number table. So it says simulate the outcomes of flipping the quarter 6 times. That's how many times that you're going to do it. So that's a 1-digit number, right? And then you might want to think assign heads and tails a value. And what I mean by if you're using this table, any of these tables, we're going to have some odd numbers and some even numbers. So one thing that you could do is say my heads, I might call them an even number. And tails, call them maybe any odd number would represent that. So we could use a random number table to also simulate this. And so maybe we're gonna still choose block 1 just because it's easiest. Maybe let's try row 3 again, just so you can see that it doesn't really matter, but you can survey it. Actually, I don't want to do the same one. Let's do row 1. So we're gonna write down 9, 2, 6, 3, 0, 7, 8, 2, 4, 0. This one's easy because we're just splitting them in groups of 1, because if we're only doing it 6 times, that's a 1-digit number. So all of these are just individual numbers, and really I only needed to write down, I guess I needed 2 blocks, but because I need 6 digits, but you can go ahead and separate them up if you want. Because really we're just deciding if it's even or odd. So 9 is an odd number, so that would be tails. Okay. And 2 is an even number, so that would be heads. 6 is an even number, so that's heads. 3 is an odd number, so that is tails. 0, so we would not assign 0 to anything. We don't call that even or odd. We just call that, that's just a number. So you kind of skip over your zeros. And then we get to go back here. So we did need to definitely write some more digits here, or go through our list and separate them by ones. 7 is an odd number. So we said odds are tails. 1, 2, 3, 4, 5. And remember, we're doing this 6 times. So I need to have 6 samples here. And 8 is an even number, so it's heads. So, going back over that, what this does is it's the random table is supposed to help you simulate the outcomes of flipping a quarter if you didn't really have a quarter. And it's just random. The random number table, you just randomly pick the block in a row, and then that could simulate it and do it for you instead of just you doing it in your own head, thinking that you're doing it randomly. The next example, use a random number table to pick a random sample of 30 cars from a population of 500 cars. So if the population is 500, that means you're going to use a 3-digit number. But doing 30 is going to take us a really long time. So let's just, for instances, change that to 3. So we're going to have a sample of 3, right? You're gonna have 3 different things here. And we're still gonna use our random number table, and we're gonna choose, maybe we choose from block 2 for fun, row 1. And if you look at that block 2, row 1, it's right here. So I'm just gonna start writing numbers from that space on my random number table. So block 2, row 1, we would start with 2, 8, 7, 0, 3, 5, 1, 7, 0, 9, 9, 4, 4, 5, 6. We really don't have to go too far with this list since we're only doing 3 cars, a sample of 3. So we just need to split this up into 3 digits. And if it's out of 500 cars, the numbers have to be 500 or below. So this is below 500. This is below 500. 170 is below 500. This one wouldn't have been, if we were gonna do 4 of them. Say we did 4, we couldn't include that one, but we could include this one. Okay, so that's teaching you how to use a random number table. A random sample is the best sample. I know there are apps out there now that kind of do that for you. If you've seen on social media, whenever they pick, like you enter names in a list and they pick somebody randomly. This kind of simulates that so that the person has no control over the outcome whenever they take the random sample if they're using the random number table. Okay, on page 9, we're going to go over this example here so that we can practice a little bit of identifying the different types of groups or types of sampling that we learned about. Kind of went straight into you working with a random number table after we learned about the different sampling techniques. And so we're going to go over an example here to be able to identify that maybe from this example. So Modern Managed Hospitals, MMH, is a national chain of hospitals. Management wants to survey patients discharged this past year to obtain patient satisfaction profiles. They wish to use a sample of such patients. Several sampling techniques are described below. Categorize each technique as a simple random sample, stratified, systemic, cluster, convenience. Systematic, so systemic, and I closed on it, systematic. Randomly select some MMH facilities from each 5 geographic regions and then include all the patients on the discharge list of the selected hospitals. So we are selecting some of the facilities from 5 different regions, and then we're including all the patients from this facility. So this one would be an example of a cluster. So remember, it's not like they're choosing some from every 5 regions, that are in different locations. They just choose maybe a couple, and then they try to sample all the patients from that area for those specific facilities. Instruct each MMH facility to survey 10 discharge patients this week and send the results. So probably this one would be pretty convenient, right? They're like, oh, let's hurry up and get some data this week because we haven't been doing it. And so that would probably be convenience. And then, kind of going back over to our definitions. It says they did instruct each facility to survey 10 patients this week, so it also could be the stratified, right? Where maybe they have 5 different facilities and they surveyed 10 from every single one, so it could also be considered stratified. Sometimes you can identify it as more than one technique in this case. Because they definitely just did the first 10 discharge patients this week. Just whatever was easiest. But it also was separated in those groups, which is different than clusters because they did survey from every facility, not just some of the facilities. And then obtain lists of patients discharged from all NMH facilities, number these patients, and then use a random number table to obtain the samples. So this would be a simple random sample. And we know that because use the random number table to obtain the samples. So that would be an application of the different techniques that we learn, sampling techniques that we learn about in this unit. And then also in the 1.2, an important concept that you learned today was how to use a random sample table. Instead of maybe just using some other device to do it for you, we can choose the blocks and then we separate them in rows, and we can just go from any row. And what is good to get from that, if you didn't quite pick up on it, is like in each of these examples, you need to know how many digits to separate your list from, and it would just be like however many are being sampled. So like if we have 50 students, right? That means each student is given a number, 1, 2, 3, all the way to 50. So you would have 2-digit numbers to pick from, and it couldn't be any number over 50. This one's a little bit different because we are simulating heads and tails. Those aren't actual numbers to qualify them. It's either an even number or an odd number. So we do just separate this one as 1 digits, and then we just decide if they're even or odd to go pick from that list. It doesn't matter if it's over 6 or not, okay? But then this one we chose, we're gonna have a random sample of 3 cars. I changed it from 30 because that would make this problem go on and on forever. Out of a population out of 500 cars. So each car gets a number, and there's 500 total cars, so 1 through 500. So that's why we would use 3-digit numbers in this one. And it has to be some number 500 or below that we pick to qualify it. So like I said, if we were gonna do 4 in this one wouldn't have applied because it was above 500, but we could have used 456.